Good morning, one and all. Here I am to present my Data Analytics Lab oral examination presentation. My name is Kathane. I am from E&TC and my seat number is 33. So the outline for our today's presentation will be first exploratory data analysis. Second will be explaining the box plot method. Third is explaining and performing lasso-regression-auto analysis. And the fourth will be execution of a code. Starting with our first topic, exploratory data analysis. We'll be covering what is exploratory data analysis. I'll be speaking exploratory data analysis as EDA. Objective of EDA and how to perform EDA using Python. Starting with definition of EDA. So EDA is a basically technique which help us to form meaningful relationships or form relationships between the variables inside the datasheet or database that has been provided. So it's basically exploration technique which help us to understand the different aspects of the data. Moving on, what's the objective for EDA? It's to clean the data. That means the data must not have redundancies, some null points and unnecessary data. Second is to identify the variables. Data can be full of unnecessary variables, so it's always important to identify the variables which can be helpful to us and neglect the variables which are of no use. Third is to identify quality points in data. Means the data, the quality points will help us to understand and observe the trends and some points which can be helpful in our research purposes. So it's always important to identify quality points in data and then understand the relationship between variable. Suppose if we have given any two variables, then EDA help us to understand the relationship between two variables and find something meaningful in that. Moving forward further, let us see how can we perform EDA using Python. So there is no particular process that is mentioned to perform EDA, but it can be generally categorized into three points. First, understanding the variables in the datasheet. Second is to clean the data. And third is to analyze the relationships. Moving with the first one, what exactly understanding data means? Whenever you have given a data sheet, understanding the main points like how many rows are there, how many columns are there, what type of data is present inside the data sheet, and the another factors like this are considered under understanding data. We'll be discussing about some commands, some functions which can help us to do so. Starting with the first one, here is data.head file. It will help us to print the first rows of the data. If a particular number is mentioned inside the bracket, it will print that many number of particular rows, the first. Then when we use data.tel file, here what we are doing is we are printing the last rows of our data sheet. Again, if any particular number is mentioned inside the bracket, it will print that many numbers of rows starting from the end. Next is data.describe file. It helps us to show the integer values, integer data type values that are particularly present in our data sheet. Then data.shape. It helps us to know exactly how many numbers of rows and columns are present inside our data sheet. It will print the information in the format of rows, column. Then data.column. It helps us to print or show all the data that is present inside a particular column. Next is data.unique. What is help us is for every decided title or every decided variable, how many types of data types or how many types of entries are submitted. For example, let us check that we have given an option of a variable name as gender. Then there we can put either male, either female or other in that particular title, under that particular title. So there are three types of variables, three types of outputs that can be get under that particular variable. So when you use data.unique function, you'll be see that the output is 3. Why? Because under the variable gender, there are three types of inputs that we can get. That is male, female and other. That is data.unique. Then moving is data.d types. For every variable, which type of data type is taken as input, that particular thing will be printed using data.d types. It checks and prints the data types. Next, cleaning the data. What exactly cleaning the data means? It means to remove all the redundancies and the null data that is present inside our database, which is of no use and it's lagging the data. So in this we remove irregular data like outliers, then unnecessary data, the data which is repetitive and doesn't make sense in the database, and the third is inconsistent data, like for any particular variable, if the data is not consistent, that is called as inconsistent data. Moving on, the next is so the files that we are use or the commands that we use here are, first is data.drop. In this file, whenever you put a name of column, it will show you all the irrelevant data under that particular variable. Next is rename function. It will help us to rename a particular column as we want. Then duplicate rows data. It is basically allocating a variable for the duplicate data that is present inside a database. Next is data.drop duplicates. It helps us to drop all the duplicates, means remove all the duplicates that are present inside our data. Next is to remove the null data. For any particular variable, if the entries are not present or the entries are not given, that particular data is called as null data. So print data.isNull.sum helps us to find the null data and remove it. Moving forward with the analyzing the data, that is relationship analysis. So we use different types here to analyze the relationship between the variables. The first of them is box plot. Box plot is one of the most efficient way to summarize data given. It's a 5-number summary which includes maximum, minimum, median, and other information. So the syntax here is we are using SNS.boxplot is equals to data and the parameter which we want. Okay, the next is we'll be seeing everything in example 2. The next is histogram. It helps us to understand the frequency of particular variable, like in a particular time period or in a particular variable, how many time a data entry is repeated. That can be analyzed using histograms. Next is heat maps. Heat maps help us to understand the relationship between each variable, each two variables inside the database. The next is scatter plot. It helps us to understand the correlationship between two variables. Now, let us discuss about an example for exploratory data analysis in Python. Here we are taking a database of a car company actually. So the first process, the first thing is to import all the libraries, pandas, numpy, seaborn and matplotlib. Then the first file that we had, first we will read the file, read pd.read.csv. It helps us to read the CSV file. Then df, here the name of our file, the data that we are using is df. So df.head will help us to print the first 5 rows of our database. Moving forward, next we have df.tell. It will display the last 5 rows of our database. Then checking the types of data. df.ttypes, as we can see here. Here you can see that variables are make, model year, engine fuel type, engine HP, such variables. So what data type df.dtype will help us that what kind of data type is been given as input to the in the particular data sheet. So make object, model object. It is basically telling us about data type of the variables. Then dropping irrelevant columns. It comes under cleaning the data. So here you can see that engine fuel type, market category, vehicle style, it's not needed when it comes to our data. So as you can see here, this certain EDA, because there would be many columns that would never in some case drop it. So in that case, such as engine fuel type, market category, they are not used. They doesn't make sense in this particular database. So we'll be removing all those columns. Okay. Next, we are renaming the columns. As you can see that df is equal to df dot rename columns. Here we rename the columns using semicolon. First of all, we'll be giving the existing name. Sorry for that. Existing name, and then our what name we have to put. It's like this. Let me show. It's like you'll be first typing existing name and then semicolon and rename. The name we wanted to give to the particular file. Here, what we are doing is we are naming engine HP as HP. As you can see here, engine cylinder as cylinder, transmission type as transmission, and drive mode, drive wheels as drive mode. Moving next, dropping the duplicate rows. df.shape. As I told you, the df.shape will print the number of rows and column in format of rows and column. So here we have 11,914 number of rows and 10 columns. Next, we are checking how many number of duplicate rows are there. Here we can see that there are 989 number of duplicate rows and the 10 columns. Then we can remove the duplicate data. So here we are using df.drop duplicates. It is helping us to remove all the duplicate data that is present inside our database. Then dropping the missing null values. As I have told that for particular variable, if the value is not present, that particular thing is called as null values, and it can unnecessarily lag the data. So we need to remove the null files from the data. So here df.isNull.sum is helping us to remove all the null data that is present inside our database. Here we are using df.drop init to drop the missing file. That means to remove the missing files that are present inside the database. Okay. What exactly outliers are? It is a set of a point that are different from the other points. Means that doesn't come under the maximum and the minimum criteria in the database. So to detect those outliers, what we use is we use a box plot. Here, as you can see, this particular dot shows us the outliers. This is our maximum limit, this is our minimum limit, and this particular dots are showing us the outliers. As we have checked outliers for cylinders, HP, and the prices. Moving forward, we are checking the quantile. Quantile is basically IQR at this particular line is known as quantile. This is our minimum quantile and this is our maximum quantile. Next, moving on, different plots. So first of all, we are using scatter plot. Starting with the scatter plot. See, what scatter plot help us to understand correlationship between two variables. So here the two variables that we have taken are price on the y-axis and HP on the x-axis. This scatter plot is helping us to understand the correlationship between those two parameters. Next is heat map. What heat map help us to? Heat map help us to find all the dependent variables that are present inside the database. As you can see here, on the y-axis, we have all the different variables that are present, and also on the x-axis, we have different variables present. So, the first box tells us the relationship between price and year. Here, MPGC and year. Like that, we are seeing the relationship between every two variable that is present inside our database. Next is histogram. What histogram helps? It helps us to understand the frequency of the variable in particular interval. So as you can see, there are the companies who makes those cars and number of cars. So you can see that Chevrolet has made around 1,000 cars and Ford has made around 800 cars. As in this graph, you can see that we are able to see a relationship between every, like which cars are made and how many cars are made by which companies. This was the 4 types of plots that we have discussed here. Start with the second topic of this presentation, that is explain box plot method. Here we'll be covering what is the box plot method, understanding box plot method, and what are the applications, like why do we use the box plot method. Going by the definition, what is box plot method? In descriptive statistics, a box plot is a method for graphically depicting group of numerical data through their qualities. So it's a 5-member representation which help us to understand, which help us to summarize the entire data in the form of graphical depiction. Now, understanding the box plot method. It is a summary which includes 5 main factors. That is the minimum data entry point. Second is first quartile. Third is median. Fourth is third quartile. And fifth is the maximum value, the maximum data entry that is present inside the database. So let us know how do we find those 5-member summary. The first is the minimum. So first of all, we need to arrange all the data in the form of smaller to the large, that is ascending format. And the smallest data point that is present inside our database is the minimum point. Second is median. So we have to do the same thing. First, we have to arrange all the data in the ascending manner. So median is basically the average of 2 middle data points in the list. So if the center of the data point, if it's a database with odd number of data entries, then the middle entries will be the median of data. But if the database is even, then the average of 2 digits who are present in the median in middle of the data will be our median. Next is first quartile. So after the same thing again, we will be arranging the data in the ascending format. And then first quartile is when we divide the data from the first 50% of the data, the median, what median we find is known as first quartile. That is basically 25% of the data. Then the third quartile. After sorting all the data in the ascending format, what we do is we find median from the other 50% of the data that we have segregated. Like from the middle of the data, right side of the data, we find the median. That is known as third quartile. And the last is maximum. While after sorting all the data in the form of ascending format, the largest data entry point that we get is the maximum of the data. The other parameters that we can observe in the box plot method are the interquartile range, which means the middle 50% of the score, the range between 25%, that is first quartile, and the third quartile. The space between those is known as interquartile range. The next is whiskers. So the upper and lower whiskers represent scores outside the middle 50%. Like the scores scores on the both side of the interquartile range are known as whiskers. The second is outliers, the observation that lies an abnormal distance from the other values in the random sample form of the population. Like any data entry which is out of the minimum and the maximum set points in the database are known as outliers. So here we can see a representation of a box plot. As this is our data, here this is the max point of the data, this is mean point of the data, this is a lower quartile, which means in between of minimum and the maximum, the 25% data, that is our lower quartile Q1. Median is average of the two middle entries, that is median. Then lower quartile is 75% of the data, that is median of the right average of the right side of the data, median of the right side of the data. And whiskers are the data points from the lower quartile to the minimum point and to the upper quartile to the maximum point. And this 50% of the range is in quartile range. Here is a better representation. The minimum of the data, maximum of the data, and any data entry that are present outside of this are outliers. As you can see that this is outliers and this is outliers. The 50% data which is present between 25 percentile, that is Q1, quartile 1, and Q3 is in quartile range and median. Why do we exactly use box plot method? It is one of the best method to summarize the data because it helps us to know all the important qualities and the factors that are helpful to understand the data. So it's very handy and it is easy to use method. That's why it's excessively used in the EDA. So the third topic for our presentation is to explain and perform lasso-regression-auto analysis. What we'll be seeing in this particular topic is, first, what is lasso regression? Second is, why do we use lasso regression? And implementation of lasso regression auto analysis. Starting with, what is lasso regression? It's a type of a linear regression that uses shrinkage. It works by the introduction of a bias term, the absolute values and the slope is added as a penalty term. It is basically used to minimize all the errors and get the value as close as possible to the ideal data set. So the formula for the lasso regression is minimum of sum of squared residuals plus alpha times of slope, magnitude of slope. Here the sum of square residuals is same as that we used in linear regression. The only term that has been added is alpha times the magnitude of slope. Here you can see this is the green graph, the blue line shows us linear regression. The ideal point, the ideal data set for our assumption. Then the black one is lasso regression. Here the extra term is added, the penalty term is added, that is alpha times of magnitude of slope. Then what exactly is dependency of alpha? So as we increase the alpha, the slope of regression line is reduced and become more horizontal. That means it helps us to penetralize the line of the graph. And as alpha increases, the model becomes less sensitive to the variations of the independent variable, means it becomes less biased. Then why do we use lasso regression? First of all, it helps us to overcome the overfitting. Overfitting is the error that comes between the ideal data line and the data entry that we are checking. Then lasso regression is can be useful if we have several independent variables that are useless. Means if we have a data that doesn't have anything to do with the database, yet lasso regression can help us to find the accurate assumption and accurate possibility. Ridge decision can reduce the slope close to zero, but not exactly zero. The formula for the ridge regression is that we add a term alpha times of square of the slope. So as the slope is getting more steep and steeper, it can be close to zero, but it cannot be exactly get close to zero. But we overcome that thing in lasso regression. In lasso regression, we reduce the slope to a point where it can be exactly equal to zero. Then we'll be seeing implementation of lasso-regression-auto analysis. Now let us understand how to implement lasso regression using Python. Here we are taking an example of predicting a price of Bangalore houses in the Bangalore basically. Then let's move on. First of all, we'll start with loading the libraries. Here we are using pandas, so we'll be importing pandas as PD. Now loading data. Here we are using pre-existing data. So here what we are doing, we are loading the pre-existing then we are reading the data. Here df head, we have learned that df head, what it does, it prints the first rows of the data. Okay, then here we can see the next is we're splitting data. What does splitting data means? What the split data does is split helps us to convert any given data in the form of list. Okay, so as you can see here, we are first using sklearn model selection here, and we are importing train, test, and split. So let us understand the meaning of each and every word used here. So train is used to select the data that we would be using to train. Okay, next we are using test to select the data to test Then as you can see, I mentioned it here that split helps us to convert any given data in the form of list. Sorry for the mistake. List. So now let us understand this particular statement. So train, test, split. Here x is one parameter, y is one parameter. Test size basically tells us that which is mentioned here, that test size is equals to 0.2. It explains us that only 0.2%, that is only 20% of the data will be tested, and the rest 80% of data will be trained. So from the entire data, we are just using 20% of the data to be tested, and the rest 80% data will be trained. Here the random state 51 describes that randomly the data will be shuffled for 51 times. Here we are just allocating some variables, that is the shape of xtrend dot shape, and all the variables like that. Then feature scaling. What is it doing is it is helping us to train all the data that we are using to train. Then implementing lasso regression. From the sklearn linear model, we are importing ridge and lasso. We don't actually need ridge, so we are just importing lasso, and here we are giving the function that ls is equals to lasso. For ls fit, we always use trained data. Whatever the data is trained, we use it for the ls fit, and ls.score, we use the data which is been tested. Here we are taking alpha, the alpha is 1, so we haven't mentioned it, and there we are also testing the entire data for different values of alpha. Now let us try to run all the code. As you can see here, df.head file, it has printed first 5 rows of our data. Then the split data, it helped us to know first the shape of x and y. It helped us to know how many rows and columns are there inside our data. Then the split has helped us to convert the data in the form of the list. In here we are also knowing that what is the shape of x string, which means, as I have mentioned it here, that the test size, only 20% of the data will be gone in testing and the rest of the data will be used for training. So the shape of x string, how much of data is used for being trained is this: rows and column, like 96 columns and rows, and 107 of columns. And similarly, shape of y train, shape of x test, the data which has been used for testing, and shape of y test. Moving forward, let us understand C. Now, whenever you are implementing the lasso regression here, we can see that this is the accuracy that our model is providing us. Let us observe it with the different values of alpha. So when the value of alpha is 1, it's 0.803. That means the model is 80.3% accurate, 80.36% accurate. When the value of alpha is 2, the value comes out to be, the accuracy comes out to be 0.18. That means the model which we have designed is 81.6% accurate. And when we use the value of alpha as 3, the outcome that we get is that our model is 82.64% accurate. As we have studied about how value of alpha changes the accuracy, changes the lasso regression value that we get, you can clearly observe that with increasing value of alpha, the value in accuracy is also increasing. Okay, so let's move towards the execution of our code. The code that we have today is for ANOVA testing. ANOVA testing is basically analysis of variance. We use it as it makes it easier to test 3 or more variables, and it can provide us less error than any other method. So first of all, we are importing all the dictionary that are required. Here we use these names as, like, we are importing numpy as np, seaborn as sns, pandas as pd, and url lib.request as url lib.to. Why do we import those dictionaries as np, sns, pd? It's because this will help us reduce the time to type the entire name of dictionaries time and again. Okay, that's why we import all the dictionary just like numpy as np and seaborn and sns. We use short forms for them. Then moving forward, here we are having 3 URLs. Okay, so our URL A is this. It's for store A. URL B is for store B, and URL C is for store C. Now, our next function, what is it doing? URL lib.to.url open the URL, then .read.decode. What exactly every function is doing here? Let us see that. First, URL lib2 is the dictionary that we are using here. Then read. Read is used to read all the data that is present inside the URL. Okay. Then next, decode. What decode is doing here? Decode is helping us to decode the 8-bit AICII code here. What is it helping us? Decode is helping us to decode 8-bit ASCII code here. Okay, so clear with this particular statement? Okay, then next, moving forward here, what we are doing in this particular thing, in this particular command. First of all, np.sArray is accessing numpy as array. Then what split is doing here? The function split help us to convert any given data in the form of list. So if you have given any data for say, so this particular split function will what do? If I had given this line, split the data by new line, it will create, the split function will help us to create a list out of this particular string. Then here we have mentioned asterisk float. What is it doing? Asterisk float is accessing all the data that is present, inside the URL, in the form of float. In the form of float is the data type we are accessing here is float. Moving forward, then here we are creating the data frame. Data frame is basically a data sheet which is made out of columns and rows. Then we are using meld function here. Data.meld function is we are using there. It help us to create create a table which make it easier to access all the data present inside the data sheet. Then it's the next function here. We are performing mean. We are finding mean for the store A, store B, and store C. Then running a one-way ANOVA test. What function? Test space ind is testing the t-test for two or more independent sample of source. And what F1 way is doing here? It is performing one-way ANOVA test. Then again, after the cell campaign is run for store C, we are again repeating the entire process here, and then we'll be finding our ANOVA test for the store C, which is new store C. Let us run the entire code here. Okay, let us see what we are getting. Okay, so you can see here we got matplots. We are getting matplots here, which is helping us to understand the data better. This is the box plot, which is helping us to understand what kind of data it is, what are your maximum value, what is its mean, what is its median, and what are the maximum and the minimum value. Next, we can see the mean of both all the three stores. The mean of the first store is 58.35. Store B mean is 55.754, and the mean of the store C is 56.767. Then we are checking for the ANOVA test of all the three stores, and it we found out to be 0.32132. Now, as we have seen that we are changing the data for the store C, so we'll be doing the entire process again. Here, rather than using the C store C, we are using store C new. So here is the matplot for the same. See here, we can observe here that the store C which is present here and the store C which was present in our first code are different. We are using the new database for this now. And again, we'll be performing the same test again. And now the value for our ANOVA test is 0.01859. Thank you.